Welcome to my channel. I'm Zhangjing Xu. Let's look at the problem 44 in chapter 24. Chapter 24 is about capacitance, dielectrics, electric energy storage. So there you can see we have capacitor. The charge it carries is Q. And then we see the separation of the two planes. The distance is becomes 3 times, right? It's tripled. That is 3 times. Ask you by what factor does the energy storage of the electric field changes. So how can we do that? We can see for the capacitor, we want to find the electric energy. We have two functions. One is about the charge, another is about the potential, right? There is a given quantity is about charge, so we look at this one, right? So we can write the equation for the electric energy on the charge. This is the Q squared divided by 2C. C is capacitance. Now it looks like the C. Does the C changes? Yes, because we can see C capacitance is determined by epsilon naught times A divided by D. This D is the distance between two planes, right? It tells you the keyword. The D2 equal to 3 times D1. We can consider D1 is the initial distance and D2 is the final distance. So the final distance equals 3 times of initial distance. This is how the capacitor changes, right? Now we need to find the energy changes in this process. So we use the final energy, U2 divided by U1, right? Initial energy. And then we input the U energy inside. You can see this Q is constant because it tells us it's a fixed charge. So Q is the same. And then the U2, so there is a C, we write it as C2, U1, so we write it as C1, right? Now you can see for this equation, it can be simplified as C1 over C2, right? Q, 2 cancelled, so C1 over C2. Now, can you find the ratio for the C1 over C2? Yes, you can consider the function at there. So input C1 and C2 inside as D1 and D2, right? And you can see epsilon naught and A can be cancelled. So you get the U2 over U1 equal to D2 over D1. Agree? And then as it tells you, it is tripled. So D2 over D1 is 3. The next one asks you how much work must be done to increase the separation of planes from D to 3 times of D. So in this case, we can see, as we talk about, U2 should equal to 3 times U1. Do you agree? Yes. So the energy changes we can consider as the final energy minus initial energy, right? So use U2 minus U1. This is the energy change. And then we know U2 is 3 times U1. So U2 minus U1 equals 2 times U1. Agree? Now we need to replace U1 with the given quantity as a Q, as a A, as a D. It's easy, right? As we think, the U1, we consider this function can write as Q squared. This is charge squared divided by 2 times the capacitance, right? And the capacitance can also be replaced in this function, right? Yes. And then we input the capacitance as epsilon naught A divided by D1. Agree? And D1 is just a D. So we get it there. Thank you.